So here's some background for you. Pythagoras was the person who discovered this. He was one of the original mathematicians, the Old Greek, so I guess you could call him an OG.
You've been waiting to say this.
Actually, it just dawned on me right now. Old Greek. Very special relationship between the sides of a right triangle. Just so we're all speaking the same language, a right triangle means there is a triangle that has exactly one right angle. A right angle is a degree that equals, is an angle that equals 90 degrees. Okay? This should not be new to you. Okay? An example is something that looks like this. Okay, there's several things about this picture that I want to go over with you. First off, this little box here is a symbol that tells you that this angle is a right angle. Okay, it equals 90 degrees. If you see that box and nothing else, then you know that that angle is 90 degrees. The only other way that you would know is if they wrote 90 degrees in there or in the problem itself, and this, let's say this angle was labeled, and in the problem it said this angle, whatever angle it was, equals 90 degrees. You cannot assume from a picture, unless this box is here, that the degree is 90 degrees, that it's a right angle. Even if it looks like a 90 degree angle, if it's not labeled or it doesn't say in the problem, you can't assume that it is. Okay? This side here is the hypotenuse. The other two sides are called legs. And I'm going to talk more about that, those definitions and that terminology on the next slide. All right, so here it is. Some definitions. The longest side and the side directly across from the right angle, meaning here's the right angle, directly across from it, the hypotenuse. Okay, always. The other two sides are legs. They are shorter than the hypotenuse since the hypotenuse is the longest side. That relationship is going to be important. Here's how it applies the Pythagorean theorem. Okay, this is actually the Pythagorean theorem: a squared plus b squared equals c squared. Okay, c is the hypotenuse because it is opposite the right angle. Now, it doesn't matter whether the longer side is A or the shorter side is A. Just know that one of the sides, one of the legs is A, one of the legs is B. It doesn't matter. I could have easily have put in B here and put A there. It wouldn't have made a difference. Okay. The key thing is understanding that the hypotenuse is the one that's across from it. Okay. Now, again, and that's what this says. A and B are the legs. C is the hypotenuse. Here's an example. Okay, so go ahead and solve this problem. Okay, go ahead and solve this problem. So, what you should have had set up is this: 5 squared plus 12 squared, since those are the legs. C is the hypotenuse, is c squared. And again, if you weren't sure where to put c, okay, or which one you were trying to find, you just find the right angle and know that opposite it is what we're looking for, which has to be the hypotenuse, so it has to be over here. Okay, so this is 25 plus 144 equals c squared. So 169 equals c squared. How do I find c? Square root of both sides. Now technically, I should take the plus or minus. Why does the minus not apply here? You can't have a negative length. Okay, whenever you square both sides, it should be plus or minus. But the fact is, I can't have negative 13, and it has to be centimeters. Okay, if you leave the label off when you do these, I'm going to take points off. You need to label them. There is context here. Now, that being said, if you were given a problem, the exact same problem, and they didn't label it in the problem, whoa. Okay, and you went through and solved it, your final answer would now be 13 units. That's how you would answer it if there were no labels. Okay, if there are no units labeled on there, you would still write the word units to indicate that it's some type of measurement. Okay? Make sure you put the label, make sure you put the unit. If the problem does not provide units, make sure you write units. Okay? How many had that? Good. Let's look at another one. Do this one. So that one we were looking for the hypotenuse. This one they give us the hypotenuse. Instead we're trying to find B, so go ahead and do that. So one of the things that you're going to have to do is you're going to have to put the answer in the form that the directions tell you. In this case, there are no directions. Okay? So I'm going to show you what an exact answer looks like and what a rounded answer looks like. The directions will tell you if it's exact, it needs to be in this form. If it's rounded, it has to be in a different form. And you have to just pay attention to the directions to know which one. I left them off here so I could show you both. Okay? And the reason why this is important for this particular problem is that it doesn't come out nice and evenly like the last one did. Okay? Here's my setup. Alright, so this is 36 plus b squared equals 361. So b squared equals 325. Now when I find b, I'm taking the square root of 325, which is not a perfect square. So let me show you the difference. When it's exact, what you're doing is simplifying the square root of 325. Okay? And you're going to leave it in radical form. What's a perfect square that goes into 325? A perfect square that goes into 325. 25. So this is 25 times 13. So the 25 can be simplified. The square root of 25, that is what? 5. So this is the exact answer. 5 root 13 feet. That's what an exact answer would look like. Okay? If it's rounded, and it'll usually tell you, let's say we're going to round to the nearest tenth. Okay? Then I would take the square root of 325 and just plug it in my calculator, and you get 18.0 feet. Okay? The directions will tell you which way they want it. Exact means simplified radical form, rounded to whatever place you're told to round to. Any questions about this?
No.
How many had that? Probably had the 18. Probably didn't have the 5 root 13. Okay, so just so you know, you do not have to do both unless it tells you you have to do both. Okay, I just want you to see what an exact answer looks like and what a rounded answer looks like. All right, the next piece that you're going to have to do on the worksheet for today is determine if something is if 3 numbers are Pythagorean triples. Okay, and in order to be a Pythagorean triple, you have 3 lengths that will work when you plug it into the Pythagorean theorem. And that's really what this says. If the 3 numbers given can be placed into the Pythagorean theorem and work out to be true, then it's a Pythagorean triple. If it's not, then it's not a Pythagorean triple. And the very first problem that we looked at today, that 5, 12, 13, where everything worked out nice, 5, 12, 13 is a Pythagorean triple, because when I plug it in to the Pythagorean theorem, the left-hand side equals the right-hand side when it's simplified. So when you get to this section of your worksheet today, I'm going to show you the work that you need to show in order to prove or disprove something is a Pythagorean triple. Okay? For example, 3, 4, 5 is a Pythagorean triple. That's one of the most common ones that gets used a lot. Additionally, any multiple of these numbers is a Pythagorean triple. So a 6, 8, 10 is a Pythagorean triple. A 9, 12, 15 is a Pythagorean triple. Anytime I multiply all of them by the same number, that new set of numbers will also be a Pythagorean triple. And that works for every Pythagorean triple. So like the first example, 5, 12, 13, if I multiplied them all by 2, a 10, 24, 26 is also a Pythagorean triple. Now, in order to prove it, all you have to do is plug it in and show that the left-hand side equals the right-hand side. And that's the work that you show to prove it. So in this problem, which one of these has to be the hypotenuse? Why? Largest side, okay? So when I plug it in, this is the work that you need to show to prove that 3, 4, 5 is a Pythagorean triple. It's pretty straightforward. Once I plug it in, and you force the 5 to go on the other side because it's the biggest, this is 9 plus 16, which is 25. They equal each other. So this is the work that you show in order to prove that it's a Pythagorean triple, okay? And on some of the problems today, you're going to have to do that. And conversely, 5, 6, 7 is not a Pythagorean triple. And so the way that you prove that is you plug it in again to the Pythagorean theorem. And then you can clearly see that 64 does not equal 49. And this is the work you would need to show to demonstrate that it's not a Pythagorean triple. Okay? Yep, definitely equals 61, not 64. Okay. All right, questions on any of this?
No, sir.